So we're going to spend the rest of our time on our discussion today on the topic brought up by this week's Volcano Watch, published today, remembering Maunaloa's eruption on July 5th to 6th, 1975. So 46 years ago this week, this is the anniversary of that less than 24-hour eruption, a 20-hour event with vents confined to the summit region, area above 12,000 feet or so. Right, so that summit region does include a little bit outside the caldera, but above 12,000 feet, that's essentially that cutoff zone because of the pattern of eruption there. So at the time, this was the first eruption in 25 years, which had been the longest stretch since 1843. We've since passed that at 37 years and counting right now. So I won't read everything, but we're going to want to essentially go into detail about this eruption here, so I'll pull out the important things here. It's the first eruption monitored by modern instruments, so we do have modern data, although modern with an asterisk, because 1975 modern is different from 2021 modern. So data quality is an issue, and the data sets are not exactly the same from then to now. Still, we do have more data than anything before that. And it is a typical eruption occurred only within that summit region. So they note here, all of Maunaloa's 33 eruptions since 1843 have started at the summit, and of those, about half were only in a summit region, like in 75. So 75 could be an example of that half of the eruptions on Maunaloa that begin in a summit and just stay in a summit and then end in a summit, and that's all you see. All right, so we'll focus just on that little sliver for now to start, and we'll expand from there a little bit later on. But the important things here is that unrest began clearly in April 74, and so over a year in advance, with large seismic swarms in August and December 74. Right, so April, August, December, you can see that there's a few months of activity, and months in between without, month with activity, months in between without. But there counts with a threshold of let's say 1.7, right, and things above 1.7, of about 450 earthquakes per day in August, and to December 1,500 earthquakes per day above magnitude 7. This is in December. This ended up being 6 months ahead of the eruption, right? 1,500 per day above magnitude 1.7. So to kind of step out of it here, recently in 2020, 2021, we've seen increased activity, but not to this volume right here, right? Not 1,500 earthquakes larger than magnitude 1.7. So, but the week before that was actually fairly quiet, and then that night of July 5th, at just before 11 p.m., they noted the activity escalating on the seismographs, and within half an hour, 40 minutes or so, they notified eruption was imminent, and it began about an hour after that. So it was over by 7:30 p.m. the following day. So the staff arrived at the summit area 2 hours after eruption began. They actually got there by airplane, and we'll get into that here in a little bit as well. And fountains were extending across the caldera to about half mile southwest outside the caldera, and flows going west and southeast. A few hours later, on July 6th, in the early morning, 2 a.m., fissures opened up across North Pit and northeast of the caldera, and started going northeast as well. I will show you guys some maps here shortly. I'm just going to make sure we get to the Volcano Watch here first. And that is essentially the short version of the eruption there. 7:15 a.m., the fountains stopped erupting, and the flows kind of petered out by later that evening there. So there was seismic activity for about a week afterwards, as there was a flurry of migration of earthquakes from the summit northeast to the northeast rift zone. And they did not know if that would actually erupt at the time, but after about a week or so, it quieted down, and it did not erupt until 1984, which it did from that exact spot, in fact. So that was an indication for the future eruption, the next eruption that was a summit to flank sequence as well. So we'll look at that as well. But some stats here, they say of the 14 summit-only eruptions for which we know the start and end date, 1/5 lasted a day or less, only one lasted a week or less, 1/4 lasted between 1 and 4 weeks, And 1/3, 5 of them lasted between 1 and 6 months, with one lasting several years. So they can really go from less than a day all the way to several years, and there's really no distinct pattern there, right? With 1/3 of them up to 6 months, and 1/3 less than that there, yeah. So no exact patterns there, but they do note here that they don't know when the next eruption will be, and the eruption will start at the summit if it follows a pattern set by eruptions since 1843. So that's the expectation: start at the summit, and then either stay at the summit, like 75, or migrate down a flank. Before the eruption, we expect weeks to months of unrest with a rapid escalation of seismic activity immediately prior to the eruption. As our monitoring network is more extensive and sophisticated in 1975, we also expect higher overall earthquake counts. So that is the USGS statement here on where we are and what to expect leading up to the eruption here. So that's the Volcano Watch released just today, in July 8th, 2021. And I want to show you guys some of these pictures here. So this is Don Peterson's image, aerial image here, presumably from an airplane. Looking north, Mauna Kea is here on the horizon, and you can see here the fissures in the northeast rift zone, saying lava flows down to the northeast here. 1975, there was one image. Slightly different view here, looking a little bit more from the south. Here's the summit caldera, and fissures began up here in the middle, also to the southwest, before they also later on migrated over here to the east. And here are these northeast, upper northeast rift zone / summit fissures that were feeding that flow to the northeast there. Yeah. The early mornings of July 6th there. Yeah, a little bit of close-up of one of these fissure lines, and a little bit of a spatter rampart, and you can see some cinder cone forming around here as well. And so that eruption, of course, only lasted 20 hours, so you don't really see the development of larger features like cinder cones or lava lakes or any of that kind of thing. It's just flowing downhill and some spatter ramparts, and that's basically it there, as far as the features that are left, right? Lava flows as well. And so source of a couple of these is Volcano Watch from July 1st, 2010. And this gives a little bit more of a human story of it, right? Talking about how Hawaii Volcanoes National Park Ranger Bill Fink was wide awake with all other 10 hikers in the cabin at Red Hill Pu'u'ula cabin in the northeast flank of Maunaloa National Park here, and they all woke up and saw the glow of eruption on the horizon there. So they actually were monitoring from there, looking at the horizon. They really couldn't see the eruption source. They could just see the glow from that campsite there. But USGS scientists did get in the airplane there. Yeah, I'm not quite sure if it was Jack Lockwood who was piloting that particular flight. I believe that may have been the case, as he is known to have piloted for some of those eruptions there on the HVO staff, and also a very accomplished Maunaloa researcher as well. So there's where these images come from. So they had seen some more story from this Volcano Watch. They had seen increasing signs of seismicity April throughout the year here. So they actually saw that there was increased eruption potential. So they installed more monitoring instruments on the volcano in 1975, including, I want to say, 3 new tilt meters, one of which was quickly buried by lava. So didn't get to keep them all. But they did see something building up to it for months ahead of time. So a couple of things worth reading for you guys here. Surprisingly, in the week prior to the eruption, daily earthquake counts were relatively low. But shallow seismicity increased sharply in that evening there. So let's scan down here a little bit more, and here we go. By 1:50 a.m., July 6th, HVO scientists were flying over the summit in a light plane here for direct observation of the eruption. So they noted there at that point in time, of course, that's how they had to get there. You can't really hike up that quick, and you don't know where the lava is flowing down at those upper elevations. You don't have to cut off your path. That's something to consider. So the aircraft was well used even in 75 there. So, of course, we have other older eruptions in Mauna Loa also documented by aircraft as well, whether it be Air Force or military or scientists as well. So, long history of aerial reconnaissance in Mauna Loa here. In any case, 65 to 130 foot high fountains of lava, 20 to 40 meters high, across the length of Moku'āweoweo and over to the southwest. Lava had flooded more than half the caldera floor and was cascading into 3 pit craters in the upper southwest rift zone. So let's see, there is a picture of this here somewhere. See if I can find out where it was. Maybe did I lose it here? Let's come back. Well, I don't have it here quite yet. So, well, let's show you guys this one here. Here's where the lava flow came down in 75, all the way down to close to the four-wheel drive road, just uphill from the Weather Observatory Road. So here's the edge of the flow right through here, and that's about as far as I got close to that road, right in there. So that's that lower extent of it right in there. And I'll find that picture somewhere. There. Aerial view of lava cascades into Luaho, upper southwest rift, 2:40 Hawaiian Standard Time. Cascade height about 90 meters. So over 200 feet there, 250 feet or so. RT Holcomb photographer there. Right there, lava coming down over the edge, pouring into that pit. Right over there, over the edge right in there. So that is what I wanted to show you guys right in there. So otherwise, we can, I think, wrap up this particular Volcano Watch article right in here. Lava overran parts of the summit hiking and jeep trails, but did not cut off the Maunaloa Observatory Road. So that's the interesting story there. Of course, as magma moved into the northeast flank after the eruption was over, the park ranger Fink was still stationed at that cabin and had to be evacuated because the earthquakes were all coming closer and closer to him and happening every minute or so as he was monitoring the area over there. So, all right, let me come back up here and let's do this a little bit more properly. This is one of the more comprehensive summary papers of that Mauna Loa 75 activity, tied to what happened later in '84 a little bit. And so by Lockwood et al., this is from Russian paper 1350 from the USGS that was celebrating, I forget which anniversary of the volcano observatory there, or the eruption here. So in any case, Diamond Jubilee HVO 1987, I think that was what it was. All right, so I won't read through everything here, but here's a plot of those earthquakes, right? So you can see here 74, 75, number of earthquakes per day is what's actually showing here. So you see that in April 74 it ramped up, came down, it had a couple of spikes, right? And then they actually had a big spike in December, right through here, right? And it's worth noting that in December, I'm going to scroll up here to the abstract, because in December we actually had an earthquake, a big earthquake that was the perhaps the warning that more was to come, right? And so maybe I'll come back to that here a little later. I don't have that earthquake right in front of me. But you see that we actually had these, they're actually referring to them as bursts, coming up here and up in here, and there is eruption right in there, with some quiet times in between, right? So this is 2 full years of data. So if we were to compare that to what we're seeing today, we're not really anywhere up near to these 1,500 per day volumes. We're maybe more in this range of stuff, like right through here, perhaps, right? Might be the pattern we're seeing. So there might be still more to come, and we expect to see higher counts, as well as earthquakes that set off one of the flanks as that kind of I don't know what exactly is the right word there. Words are failing me. It's that indicator that there's more to come. Dane? Oh. I can't hear you.
Microphone wouldn't unmute there. I was just saying I was going to hop in and throw words around to see if I could get you the right one.
Yeah, thanks. Yeah. All right. Well, onwards, and we've gone through this a little bit here. One interesting thing I wanted to point out here. This is a picture of pit craters in the upper southwest of Mauna Loa in April 1975. This is Luaho in the lower right corner here. This is that pit crater I just showed you guys that lava was flowing into. Those summit fissures came across here and over here, and then we're flowing into the pit crater right there. But they're showing how much snow there was up in the upper southwest rift in April 75, and you might see that maybe there is possible anomalous melting. Maybe there is a lack of snow in some of these areas because it's hot underground. There and perhaps there as well, right? The most obvious places of where you might see missing snow were perhaps because the ground is hotter there. So that's something that was noted back in April 75 that we have not mentioned yet. And so they installed more survey networks in the lower elevations, in the summit. They were cataloging earthquakes more meticulously, and during the week of June 30th to July 4th, 3 borehole tilt meters were installed on the summit and north flank. One of these tilt meters was to be destroyed by lava flow in a few hours before final adjustments could be made. And there's where that information comes from. So we've talked about the eruption sequence a little bit as well. Here are the earthquakes that were leading up to that eruption in July of 75. So you can see that there are similar earthquakes northwest, a little bit of a cluster to the north here a little bit too, and this large cloud of shallower stuff here underneath the summit and upper southwest rift, just as we see today. And these ones being more intermediate in depth, just as we see today as well. That's what squares are indicating here, as opposed to the plus signs here. All right? So a similar pattern of earthquakes, and possibility for renewed activity, as they say here. July 7th to 12th was a period of great public concern as an outbreak of lava lower along the northeast rift zone seemed possible in light of both the ongoing seismicity and the numerous historical examples of pre-summit eruptions, followed within a few days by flank outbreaks, for example, April 1942. So they knew that magma was going into that middle northeast rift zone from July 6th to 12th, with several hundred small earthquakes daily within the northeast rift zone, dozens of which felt, concentrated all in one area just southeast of Pu'ulaula, Red Hill Cabin, where the ranger was stationed. And they measured dilation in the area there, so they know that magma had come into the area. But July 10th and onwards, the tremor diminished and everything wound down to a halt and would not erupt until 1984. Now, they had actually postulated that it might be sooner than that, but the 75 south flank earthquake of Kīlauea at Kalapana, I think maybe, as I mentioned in the past, may have delayed some of that as well. So that caused them to be off, but here we get some additional images here of those fissures in the upper southwest rift zone here. Once again, early July 6, 1975. All right, here's a map of 1975 flows and the fissure lines. So this darker pink, that's where the fissures were, right? Across the entire summit of Moku'āweoweo, right? Kind of 2 trends. One that trends northeast, this way, and a junction right in the middle, and one different trend to the southwest over here that went all the way outside of the caldera, all the way to Luaho by South Pit over here, right? So that's the crater the lava is flowing into right here at the bottom, over here. And up here to the right, here's Maunaloa Observatory Road, and that's that little edge of the lava flow that came close to it up there at that northern tip over there. Right? That's the pattern of it, and you can see that it covered almost all of the bottom of Moku'āweoweo caldera right through here. Not all of North Pit or South Pit, but most of the actual main caldera itself right through here. apart from the high cones, 1949 and 1940 cones, obviously, and other high spots in there. But as mentioned in this week's Volcano Watch, 90% of this eruption was covered by the 84 activity. So we'll show you guys a map a little bit later on that shows how it stands today, with 84 covering a lot of this stuff and what's left now. Okay, so this is the earthquakes pattern during and after the eruption here. So they actually note that the earthquakes that were west of about here, so all of these ones, this is the before the eruption, was actually fairly quiet. A little bit, and a little bit, and a little bit, but really nothing like the level was before it actually fissured open, you know, all through here, right? And then after the eruption was over, the activity moved to over this way. And so all this over here in this area is all after the eruption was over, and you can see why they were so concerned, right? You see essentially along the northeast rift and maybe the south flank Maunaloa area below it, allowing movement so that this stuff can come into there. Right? So you see that magma clearly moved from the summit over here to the northeast rift. I didn't know if it was going to erupt right then and there, or what actually happened is it waited to 1984 to come out of this similar area right through here, mobilizing that same magma pathway there. We won't talk about 84 too much, only in as far as it relates to the 75 and how it fits together here. So they had noted here the pattern between summit eruptions only and then flank eruptions with different intervals of time. So May 49 before flank eruptions, and 51, 52 over here, with a gap of about 2 years or so. Sometimes you have a gap of only a few months, like in 1880. Here's another few years one again. Right, so they thought that after 75, that maybe somewhere in there you might have, after a couple years, somewhere in there you might have another eruption again. And that would have put it somewhere in the late 70s, but it took another 6 years beyond what they predicted till 84 for it to happen, perhaps because of that late 1975, November 75 Kīlauea earthquake, magnitude 7.7 by some calculations, revised since then. All right, so that's the pattern here. And that's something to think about in the future as well, is that you often do have a pattern, not always, but you often have a pattern of a summit-only event, and then you have an event that's summit and flank combined into one that follows after some time. So because our last eruption was on the flank, you might expect the next one to be one of these summit-only events. We'll have to wait and see, of course. That would be the default expectation there. And then after some time, you'd have another summit, and then moving to the flank again. And we would expect it to be the southwest rift zone the next time, since they often alternate as well. Okay, so we've shown this image before as well. This is all the earthquakes from 1962 to 1984, and this line of A to A prime here is this cross section going across this. So looking at depth, we have this pattern of the shallow earthquakes around the summit and upper southwest rift, and over to the northwest, this area to the side. So with a magma body postulated to be somewhere in here like this, with some feeder source farther down like that, right? And that's where the patterns we see today and how that all fits together, and why we've been talking about all this context, because we're seeing the same patterns today and the same sequences. We're just not seeing the numbers that we were seeing before from 75. So I'm going to skip down. I'm going to go through a lot of 84 stuff, but I do want to point out this plot here. This is cumulative number. This is earthquake numbers, earthquake counts split into shallow, 0 to 5 kilometers depth, intermediate, 5 to 13 down, and deep earthquakes. So eruptions happen here and here, and you might note that the deep earthquakes don't really change at all. Deep earthquakes are uncorrelated to anything with eruptions. You look at the intermediate and the shallow ones as what you look at. And what you might note is intermediates might come in a little bit sooner than a shallow, and it might be associated with some of these flank earthquakes, like the 6.6 right through here, and the other one is not quite mentioned, not drawn on this plot, but perhaps right in here might be where that other earthquake lands. in, I want to say December of 74. And we'll look at that here shortly as well, too. So this paper goes into 84, so I'm going to scroll down here and just point out here's that diagram: magma, body, and feeder zone. Earthquakes to the side and above, as before. We're only going to look at the 75 stuff in relation to the 84 eruption. So here is the 84 fissures fuming. I'm sorry, the 75 fissures fuming prior to the 84 eruption. And here's a 1940 cone that survived the 75 eruption. Lava flowed all around it, right, but didn't quite cover that little high spot. And this here is all 84, so we'll go past 84. We'll look at this image here. We've seen it before as well. So the 84 fissure comes across the middle here, and it cuts off the 75 fissure right through here, and actually in 84 buries all the lava that was put into the main summit caldera in 1975. Okay, just a little bit more here. I want to show you guys that last map here. So okay, here is the before 84. This is the 75 fissures here with all that lava that came out of that northeast rift near the summit, right up there. And you can see 1984, you don't even see that pattern. Everything is covered from the northeast rift eruption in 84. So easier to see in a map form. So let me get down to where that is shown as the last thing to show you guys in here. And there it is. 84 is in pink and 75 is in blue. Right? So you see that within the caldera here, just a little bit of blue towards North Pit and a northern edge, northwest and northeastern edges here. You get a little bit of it over here by the northeast rift, a couple little strands, and easiest to see by the Maunaloa Observatory Road, actually, way up there. 75 is a lot easier to get to than 84, which is easier to access. Perhaps over here when you hike up the Maunaloa Trail in the National Park. So you can see there what is left, little patches of blue, 10% of it left uncovered compared to before. 84 eruption there. All right, so that's the story of 1975, and a couple final things here to talk about. I did say that often there is a summit and then flying sequence, so I wanted to point out from a separate paper in that same volume by Lockwood and Lickman. Up here is summit eruptions since the 1820 era. Right, so you see them much more frequent. These are the half of the events of Mauna Loa at the summit. That's all of this up at the top box over here. Right, so you can see that you often have a summit. Then you might have something on one of the sides, northeast rift zone, southwest rift zone. In this case, radial vent to the northwest here. So we actually had summit, northeast rift zone, radial vent, summit, northeast rift, summit, northeast rift, summit, southwest rift, summit, northeast rift, summit, southwest rift, summit, northeast rift, summit, southwest rift. So it's not a clean pattern, but that's where this comes from. This idea that there might be some patterns in here, right? And so I show you this so you can see the natural variance as well. So even though we see that it should follow this pattern, it's not always so clean, and you might have something a little bit. You're always going to be on alert for it to break the pattern as well. Pattern, of course, is what we have to work with and what guides us, so I want to make sure to show it to you guys in this level of detail at least once here. And last thing, revisit this volcano watch from July 2011. Mauna Loa's 1975 eruption in terms of today's volcano alert level. Right, so they actually note here that I'll skip all the sequence once again, but they do say that even with the lower capabilities of detection in 1975, they might actually have in April noted a clear increase in daily earthquake counts, and they might have put the alert level of the volcano at that point up to an advisory alert level and yellow aviation color code, as we have today on a volcano, in fact, right? Similar to today. So April of 74, they would have gone into yellow and advisory, and kept it at that way as persistent earthquakes occurred all the way through. All the way through fall 74. And here we go. On November 30th, 1974, magnitude 5.4 earthquake occurred in a Kīlauea fault system underneath the southeast flank. So I was wrong, it wasn't December, it was the end of November 30th, 74. And that was the one that associates with that spike of earthquakes and that shift in a pattern of ramping up towards an eruption. That was that alert, that indicator, right? The harbinger of eruption to come there. So they say that that earthquake alone may not have warranted elevating alert level and code from advisory yellow to watch orange, but combined with the fact that in early December, earthquake counts jumped from 100 to 200 per day to over 1,000 per day, that might have been enough at that point to go to advisory, from advisory yellow to watch orange right in there. Especially when you add in that on December 15th, there was a 4.6 shallow underneath the summit, and daily earthquake counts peaked at 1 per minute, almost 1,500 per day. So if not in early December, then certainly by December 15th, they would have gone up to orange, and that's the pattern we can expect from Maunaloa and USGS today, we would hope, we'd expect as well. So a second shallow magnitude 4 earthquake beneath the southeast summit region on March 26, 75, and thereafter an apparently accelerating rate of shallow magnitude 3 plus earthquakes beneath the summit would have provided additional basis to change volcano alert level and aviation color code prior to the eruption in July. So they knew this was all coming. They published a paper saying it was coming. The paper didn't actually get published and issued back in 75 until after the eruption, but it was actually submitted for review before that. That was the era of the 70s, of course. So, but it was enough that the scientists could actually publish about it ahead of time. Yes, Dane?
They kind of need those preprint servers for that we see nowadays.
Yeah.
You can go and view the preprints as they're submitted, so you don't got to wait for that whole review process. It's, you know, going through the weeds a lot more, but you get access to the information a lot quicker.
Yeah, certainly the process would be, you know, even today we see it sped up quite a bit, and of course there was no internet back then, of course, and that was the main issue. So that's the Volcano Watch series here, and then one last thing I wanted to point out here is interesting. This is back from an article we've talked about before. Volcanic Unrest from Maunaloa. This is by Thalen Miklius and Christina Neal in 2017. And I will just come down here to point out that I'm going to read this sentence right here, which is where I get this term of bursts here. 1 to 2 years prior to the 1975 and 1984 eruptions, swarms of small earthquakes increased in intensity. The strongest swarms included hundreds of small earthquakes per day for weeks. Bursts, as they were called, were separated by 3 to 6 months of relative quiet. So you have to wonder, 3 to 6 months of relative quiet in between bursts may be a way to describe what we've been seeing in activity this week. And is this still precursor to something to come? Or is this ongoing flank movement? That's really the question that we don't know. Is this ongoing flank movement allowing the flank is it moving out of the way fast enough to allow the volcano to inject without erupting? Or is it a precursor to a bigger earthquake to come because we just can't catch up? And that's the thing to be determined, that we're still waiting to see. And the dead giveaway, of course, will be if we have something like a magnitude 5 or 6 on that southeast flank, whether it's Kīlauea or Kīlauea areas, or even on Kona side, as proposed by recent researchers who think that's the area prime to go. So we'll have to wait and see for that. So that's a little bit of everything for 75. That's the context of it right there.